Welcome back to our series on structural design patterns. Today, we're diving into one of the most practical tools in your coding arsenal, the adapter pattern. The best way to understand the adapter is to think about international travel. Imagine you've just landed in Paris, but your American phone charger has flat pins that don't fit the round European sockets. You don't buy a new phone or rewire the French electrical grid. You buy a small, simple plug adapter. It sits in the middle, translating the physical connection so power can flow. Neither side changes, yet they work together perfectly. This physical problem is incredibly common in software development. Let's look at a real-world scenario. You're building a stock market monitoring app that pulls real-time data from several providers in XML format. You decide to integrate a top-tier third-party analytics library to provide your users with buy and sell signals. But there's a major technical hurdle. This library only accepts data in JSON format. You can't modify the analytics library. It's a compiled third-party package, and you can't easily change your entire data pipeline to JSON without breaking dozens of other features. You're at a total impasse. Let's examine the code. Here is our existing data provider. It does its job well, but its output is a string of XML, totally incompatible with what we need next. And here is the library we want to use. It expects a JSON string, so it can pass it into an object. If we try to pass our XML directly, the library will simply throw a syntax error and crash our application. This is where the adapter pattern shines. It allows us to create a special wrapper object that hides the complexity of conversion. It acts as the middleman between our app and the library. Step 1. We define a clean interface that our application code, the client, will use. This interface describes exactly what we want to do without worrying about the underlying data formats. Step 2. We create the adapter class. It implements our new interface and holds a private reference to the third-party library. This is known as composition. Inside the adapter, we handle the translation. We take the XML string, convert it to JSON, and then call the library's native method. The complexity is now completely hidden from the rest of our app. Now, look at our client code. It remains beautifully clean. It doesn't know and doesn't care that it's talking to a JSON-based library through an XML to JSON translator. It just calls the interface. This gives us incredible flexibility. If the analytics provider updates their API or we decide to switch to a different vendor entirely, we only need to write a new adapter. Our core business logic stays untouched. There are actually two ways to implement this. What we just built is an object adapter, which uses composition. In languages that support it, you can also use a class adapter through multiple inheritance, though composition is generally preferred. You see this pattern everywhere in professional software. Think of database drivers. Whether you're using MySQL, MongoDB, or Postgres, your code often uses a unified query interface provided by an adapter layer. It's also the go-to solution for legacy system integration. When you need to connect a modern cloud application to a 20-year-old mainframe, the adapter pattern acts as the bridge between eras. So, when should you reach for the adapter? First, when you want to use an existing class, but its interface is incompatible with the rest of your code. Second, when you want to create a reusable class that cooperates with unrelated or unforeseen classes that don't necessarily have compatible interfaces. The pattern's true superpower is that it makes existing code work with new code without changing a single line of either original source. It preserves the integrity of your systems while enabling growth. A word of caution: don't over-adapter your code. If you have control over both sides of the interface, it's often better to just refactor the code to be compatible rather than adding the overhead of an adapter. People often confuse adapter with bridge. While they look similar, their intent is different. Adapter makes things work after they're designed. Bridge is used up front to let abstractions and implementations vary independently. Similarly, don't confuse it with decorator. A decorator enhances an object's behavior without changing its interface, whereas an adapter changes the interface to make it compatible. To wrap up, the adapter pattern consists of the client, the target interface, the adapter itself, and the adaptee, the incompatible class we're wrapping. Together, they form a robust solution for interface mismatch, ensuring your software remains modular, extensible, and clean. That's the adapter pattern in a nutshell. It's a simple concept that solves a massive variety of real-world integration headaches. I hope this helps you keep your interfaces clean. In our next episode, we'll move on to the bridge pattern, where we'll learn how to decouple an abstraction from its implementation so the two can vary independently. Thanks for watching episode 6 of our design pattern series. I'm looking forward to seeing you in the next one. Happy coding!